Hello everybody. In this video I want to talk about saving money, and in particular the ideas of simple interest and compound interest and the difference between the two. So hopefully this is a topic that's near and dear to your heart. Everybody should be interested in saving money, and there's different ways you can save money, and there are different ways you can accumulate money, whether it be putting money in a savings account, whether it be a Roth, a mutual fund. These ideas of simple interest and compound interest are very key. And you'll see one idea is so much better than the other idea. So in this video, I want to compare the ideas of simple interest and compound interest. I want to talk about the differences between the two. We'll do some calculations, and then we'll also talk about this idea of APR versus APY. Okay? So that's our goal for this video today. Today I want to start, though, with talking about simple interest. Okay, so let's just look at a problem. Again, we're going to start with simple interest. So suppose you invest $5,000 at 10% simple interest. So it'll tell you whether it's simple interest or the compound interest for 1 year. How much do you have at the end of 1 year? So a lot of you are probably saying, well, you know, I could take my $5,000, that's how much we got in there, what they call the principal, multiply by the interest rate, which is as a decimal 0.10, and then multiply by the time, which in this case is 1 year, and that gives me an interest of $500. Okay, so this is your interest. $500. So at the end of year one, you have the $5,000 that you started with plus the $500 in simple interest, so you actually have $5,500. Okay, so that's how you calculate simple interest. Pretty straightforward. You take how much you got in there, multiply by the rate, by the number of years, and that's how much simple interest you earn. Okay. Well, suppose I ask the same question and say, how much do you have at the end of year two? Any ideas? Take a quick second and just jot down what you think that might be. I'll give you, go ahead and hit pause and work on it for 30 seconds and then hit start again on the video, and let's just see if we're in agreement how much you have. Okay. Did anybody say 6,000? If you did, you're right, 6,000. Because with simple interest, you get the same amount of interest each year. Okay, it's always based on the principal that you started with initially, the $5,000. So at the end of year two, even though you had $5,500 at the end of year one, you still get the same amount of interest. So that's $6,000. Okay, so if some of you did this, $5,500 times 0.10 times 1, and you got 550, and then when you added it to that, you actually got, if you said this, number one, it's wrong. Okay, so big X. And number two, you're thinking compound interest. That's exactly what you would do for compound interest. The difference between simple interest and compound interest, simple interest, you only get interest on what you started with, the principal amount. Whereas compound interest, you get interest with what you started with, but also what you had in there initially, or what you started with, but also what you've accumulated in interest so far. All right, so there's a big difference between the two, and we'll demonstrate that either in this video, or there might be an option to look at a video of an Excel file where I show you the difference. Easy to do on Excel. So having said that, if I do the same question, I say the end of year three, you guessed it, it's going to be $6,500, because simple interest, you had 6,000 plus your 500 in simple interest, so it's 6,500. So simple interest, you get the same amount each year because it's based on what you started with each year, unless the interest rate would change. And those of you tying this into something we did before in section 3.1, this is an example of a linear growth, all right, because it's going up by the same amount, $500 each year. So if we just think of that idea of linear growth, you know, how much you started with, 5,000, what it's going up by each year, 500 times, we'll say T for years. That's your final amount. All right, so after 0 years, if you stick 0 in for T, stick 0 in right there, 0 times 500 is 50, plus 5,000, there's your 500. If after 1 year, if you stick 1 in, 500 times 1 is 500, plus a 5,000 is 5,500, which is what we said after 1 year. After 2 years, if you stick in 2, you can see it works. 500 times 2 is 1,000, plus 5,000 is your 6,000, and so forth, right? So this simple interest, you only get interest on what you started with, the principal amount, and it's an example of linear growth. I think in the section we looked at before, I have these switched around. It was your growth rate times your variable plus your initial amount. But it's the same thing. It's the same thing. Now, the formula for simple interest, is just what it appears there. The simple interest earned is equal to the principal, which is how much you start with, times the yearly interest rate as a decimal. So notice we did 10%. Decimal is 0.10. If it was 5%, it'd be 0.05 times the time in years. So the number of years that we have. So if we do another example of this simple interest formula, and I forgot to go down the bottom of the page, but we'll make it quick. Suppose you start with $15,000 and your rate, so that's your principal, and your rate is 7%, which is not realistic these days, but maybe if you're in the market or something like that, and your time is 5 years. So if I run it through this formula, my principal is $15,000, my rate is 0.07, and the time is for 5 years. And if I run that through my calculator here, let me turn it on. There it goes. .07 times 5 is equal to 5,250. Now that's how much interest is earned. All right, always got to remember what these mean. So if I ask you what's the total amount, and I'm at the bottom of the page here, but I'm going to squeeze it in here. Total amount is going to be what you started with, the 15,000, plus the 5,250 in interest earned, which gives you a total of, let me just put it up here, 20,250. Okay, I apologize for that. I was running at the bottom of the screen there. On my whiteboard, it moves up and down, but only moves down so far. So that's how you do simple interest. It'll say simple interest in the formula. It's not nearly as good as compound interest, which you'll see, but things are simple interest. If you ever take a CD or a certificate of deposit, those are typically simple interest. Your credit cards, if you don't pay your credit card off in full, the finance charge that they charge you is typically in simple interest. So there are things that are out there that are still in simple interest. So again, simple interest, you're only making interest on the original amount, the principal amount, once you started with. Okay, let's look at an example of compound interest. So now we're talking about compound interest. So you suppose, same scenario as the first example, $5,000, but it's compounded quarterly at 10%. So same interest rate, same principal amount, but compound quarterly. Instead of waiting in our first example till the end of the year to get interest, we actually get interest 4 times a year. So every quarter, every 4 times a year, we get interest. How much do you have at the end of each quarter, at the end of each compound, or quarter, I should say, and at the end of year 1? Okay, so how much do you have? So I'm going to make a little chart here. Let's just say quarter 1, quarter 2, quarter 3, 4 quarters in a year, right? And quarter 4. Now, we're going to think of it the same way. Okay, so at quarter 1, we know we started with $5,000. And I know I'm getting 10% interest, but that's for the year. These are always year. So if it's 10% for the year, that means if it's every quarter, it's only 10 divided by 4, quarter divided by 4. If it's monthly divided by 12, all right, quarter divided by 4, it's 2.5% each quarter. So this is going to be 0.025 times 1 quarter. It'd be nice if you got 10% each quarter, but it'd be really nice, but that ain't going to happen. So we'll do it this way. So this turns out to be, you know, if I just go ahead and do this on my calculator here. My calculator fell asleep again. There it goes. So 5,000 times 0.025. So the amount of interest I'm going to get is $125. So if I combine the $125 in interest plus the $5,000 that I started with, I actually have $5,125 at the end of quarter one. So we'll put the end of the quarter there. Okay. We'll go ahead and do this for each quarter, and I think common sense is going to tell us, you know, if I get interest on my money 4 times a year versus 1 time a year, the 4 times a year is going to be better, obviously, right? So now we're going to do what y'all probably want to do with the simple interest. We're going to take that 5,125 down here. That's our new principal, and we're going to take 2.5% of that for 1 quarter. And we're going to run that through our calculator. So 5,125 times 0.025 equals, so now I actually get $128.13 if I round, which is better than $125, right? It's $3.13 better. Who's going to not take that, right? So that gives me my new total. So if I add that to my old total of 5125 where I started at, I actually have at the end of this quarter 5,000, and of course money you use 2 decimal places, but $5,253.13. Okay, so I'm going to do that each time. I only have 2 more to do. So now I'm going to take that value that I just started with there, and I'm going to do $5,253.13 times 0.025 times 1 for the 1 quarter. So I'm going to multiply that by 0.025. And I get, look at that, it's even more. It's $131.33. So $131.33. And then add that to what I started with, which in this case was the 5253.13, $5,253.13. And I get 5,000. Do that in green. Not that I need to do in green, but I'll be consistent. $5,384.46. Okay, so we got 1 more quarter to go. So I'm going to take that number that we just got there. So $5,384.46 times it by the 0.05. You know, even though it's 10%, you divide it by 4 because you're getting interest on it 4 times a year. Times it by the 1. Let's figure out what that is. And look how they're going up. The first time I got 125 interest, 128.13, 131.33. So I'm going to multiply by 0.025. Of course, I don't need to put times 1 in there because we know that's going to be the same value. This is 134.61. Bringing my new total, if I add that to what I started with in that quarter, $5,384.46 to 5,000. Let me put that in green. $519.07. Again, rounded to 2 decimal places for money, okay? So that small change from compounding it quarterly to simple interest where you only get it one time a year gave me, so this is what it is for compounding quarterly. So if I go over here and do the simple interest and see what we got, 5,500 is what we got. So I actually got, what was it, $19 more in interest? And that adds up. Believe me, that adds up over time. So remember that. So you can see the difference in compounding it quarterly or monthly versus simple interest, because if this was simple interest, each time this would be $500 here, you know, right there. My principal amount doesn't change. But with compound interest, not only do I get interest on the money I put in, but I get interest on the interest I've earned up to that point as well. And another thing I want to point out to you is notice that the actual amount in interest I got each time went up. All right. So even though it's still the 2.5% going up the same amount, the same percent each time, I actually get more money each time for compounding. That is an example of, thinking back to the last chapter, exponential growth. All right, exponential growth. It goes up by the same percentage each time, whereas the linear growth, when it went up by the 500 each time in simple interest, that is linear growth. All right, so it went up by $500, the same dollar amount each time. This goes up by the same percentage each time. So if I think back to my exponential growth model, you know, it's your initial value times 1 plus the growth rate, which was 0.025 to the t. That's what it was each time. And if you put, that's the final amount that we have. So if you put t equals 1 in there, you should get the 51.25. If you put t equals 2 in there, you should get the 52.53. Go ahead and try it. Go ahead and plug in t equals 3 and see if we get the 53.8446. And let me type it in here. So it's going to be 5,000 times parenthesis 1 plus 0.025 to the third, and let's see what we come up with. And right there is our 84.45. We have 46. We must have had a rounding error in there somewhere. I wasn't paying real close attention to that. But that's how you do it, all right? And so you can see that this is an exponential model. And we know, just common sense tells you, if I say if you're investing money and if you want your money, the money you get back, you know, the interest that you earn to look like that, or if you want it to look like that, you're going to tell me it's going to be the exponential. And we'll do an example on Excel in a separate video where you can see the comparison on the two. All right. So the formula for compound interest formula is your balance after t periods is equal to your principal times 1 plus the r to the t power, where the principal is what you started with. Now the r is your period interest rate. So for the example we did, even though it was a 10% annual rate, since it was every quarter, you have to do the 10 divided by 4. So it's a period interest rate, so we're going to be careful with that, and then t is your number in years. And also be careful, this gives you your balance after at the end. So it gives you the total amount at the end, whereas the simple interest formula only gave you the interest at the end. Okay, so and I'll give you these formulas on your test. Of course, on the final, of course, your test is open book, open notes, so you don't have to worry about that. But, you know, I'll give you these formulas on the final, so you don't have to worry about memorizing. You're just going to make sure you know how to use them and what information they give you. And let me just make sure I add something to here. I almost forgot. The t is the number of periods. Okay, so it's not necessarily the number of years, it's the number of periods. For example, if I compound something quarterly, so 4 times a year for 5 years, so 4 times a year for 5 years, my t would be 20. That's how many periods you actually get interest on your money. Okay. Let's look at a question for this. So suppose you invest $25,000 at 3.6% compounded monthly. How much do you have at the end of 10 years? So if we go through and read this, so my $25,000 would be my principal. I'm going to stick that right in there. Now my 3.6 is my rate, but remember it's compounded monthly. So monthly, the number of compoundings would be 12. So my R in this case is actually 0.036 divided by 12. Okay, and then the number of periods, T, it's 12 times a year for 10 years, so it'd actually be 120. So there's actually 120 months in 10 years. So every month I get interest for 10 years, so that's 120 months. So when I go ahead and plug it in this formula, my balance is equal to what I started with, the 2,500 or 25,000 times 1 plus my rate. Now my rate is that 0.036 divided by 12 to the T power, the number of periods, which is 120. And then if you run that through your calculator, you see if this guy will wake up again. There we go. So 25,000 times parenthesis 1 plus, and you remember the 1 plus for the growth models, and these are growth models, 0.036 divided by 12, and the parenthesis, and then caret 120. That's how many months there are in 10 years, and hit equals, and we get a total of $35,000, $35,813, and the two decimal places, 93 cents. Okay, so that's actually how much you have at the end of those 10 years. So how much of that was in interest? If I say how much of that is in interest, you would go ahead and subtract those two. So it looks like it's about $10,813.93 in interest. Now another way you can think of this formula is instead of talking like what you started with and the balance after T periods, you can rewrite this formula as your future value your principal is what you started with, so that's going to be your present value. Just another way you can think of it, times 1 plus R to the T power, where that R is still the period growth rate, so you got to divide by how many compoundings there are, and then the T is the number of periods in a year. So if I have a question like this and say, well, I know, after 10 years, I need, say, $20,000. What do I need to invest now? So how much do I need to invest now, compounded? We'll go back to quarterly at, let's say, 5% to achieve this. Oops. To achieve this goal, maybe that sounds even better. Okay, so we're going to use that same formula. So my future value is going to be $20,000. So at the end, I want $20,000. My present value, I don't know. I'm going to call that P. That's what we're looking for. How much do I need to invest now? So that's what we're looking for. And then it's going to be 1 plus, of course, my R is at 0.05, but since it's compounded quarterly, it's divided by 4. And then take a second and figure out what's your T. For 10 years, compounded quarterly, so 4 times a year for 10 years, yeah, it's 40. Now, this looks kind of impressive to solve, but you know what? It's P times. We want to solve for P. How do you undo multiplying by that stuff right there? Well, you divide by it. So if I go ahead and divide by all that, that's going to give me those cancel out, of course. That's going to give me my present value. If I type that in my calculator, carefully type it in, 20,000 divided by parenthesis 1 plus 0.05 divided by 4 and parenthesis caret to the 40 power. Hit equals, and you know it's going to be a number less than that. It's going to be $1,200 or $12,168.27. So that's what I would need to put in now, where if I compound it quarterly at 5% in 10 years, I'm going to have my $20,000 goal. Okay. I think the last thing I want to talk about in this video is the difference between APR and APY. APR is the rates that we were given as your annual percentage rate. So like 5% or 7%. I think the one we just did was 5%. We did a 3.6%. But the APY is called annual percentage yield, and it's actually it's the actual true percentage that you get. For example, we did an example at the very beginning. Let me see if I can find it. Right here, this example right there, where it's compound quarterly at 10%. Well, you and I both know that 10% of 5,000 is 500, so it should be 5,500, right? But I actually ended up more than 5,500. So it's actually the true percentage that I actually got due to the compoundings was a little bit more than 10%. All right, that's what your APY tells you. All right, so it's very important. So if you're ever, let me go back to that same page. If you ever get in this, a circumstance where like one might be 3%, 3.6% APR compounded, maybe quarterly, where the other one is 3.5% APR compounded monthly, which is better? I mean, you want to say the 3.6 is better because it's higher, but you know what? This is compounded 12 times a year. This is only compounded 4 times a year. I don't know for sure. That's when, if you knew this APY, the actual true percentage that you're getting on a return each year, you would know. All right. Instead of comparing apples to oranges, it makes you compare apples to apples. All right. And what it is, the formula is this: the APY. The formula is this: the APY is equal to 1 plus the APR divided by n, where n is the number of compoundings. So this n that you're dividing by and that n are the same. Let's get that out of there, minus 1. So in the example that we did for simple interest, the APR was, I think, 5%. Let's just go back and look at that. 10%. It was 10%. Okay. And compounded quarterly, so our n is 4. So if I go to do this, 10%, n equals 4. So if we go ahead and calculate this, it's going to be 1 plus 0.10 divided by 4 to the 4 power minus 1. And if we run that through your calculator, of course, I'm always at the end of the page when I do these. So 1, nope, I need parentheses. 1 plus 0.1 divided by 4 to the 4th power, and then make sure we get off the exponent, minus 1. It actually, and it's going to be slightly around 10%, but it's going to be a little bit more. It's actually 0.1038, say, so 10.38%. So in that scenario, even though it was 10% APR because it was compounded quarterly, I actually got 10.38%. And just to show you something else, let's just see if this works. Let's just see if this works. Remember in this example that we looked at where it was where it was compound interest, compound quarterly at 10%. How much do you have at each compound period? So remember, we started with $5,000 and we ended up with this $5,519.07. If I say find the percent increase, we know it's not 10% because 10% would be the 5,500, but we know what we ended up with, what we started with, divided by the original. If I run that through my calculator, we might be off slightly here due to rounding. Minus the 5,000. And then divide that by 5,000. Look at that. Compare these two numbers right here. Look at that. That's a percent we got using the formula, and this is a percent we figured out percent increase on ourselves. So it is slightly more than 10%. So if you want to know the true percentage rate that you actually got, it's the APY. So sometimes banks will list APR and APY, and typically the APY is a little bit more than the APR, not a lot more, but a little bit more. So remember that, the difference between those two. It's kind of important. Okay, definitely last thing I want to talk about is this rule of 72. And all it is, it's an estimate for how long it takes something to double. And it's called a rule of 72, and I'm not going to get into math behind it because it's 72 divided by your APR. So if I have an APR of 5%, the amount of time that it takes to double would be 72 divided by, now this time just put your 5 in, don't make it into a decimal. 72 divided by 5, so 72 divided by 5. It'd take about 14.4 years to double. You can figure that out exactly using logarithms or Excel, but it's just an estimate. Rule 72, an estimate for doubling time. Thank you very much.